Okay, this is engine systems. It's the second set of theory assignments. There's 7 main systems of a 4-stroke engine that make it operate: starting, charging, cooling, ignition, lubrication, fuel and exhaust. So we've just got a sketch here, the bits that make up each of these systems. So with starting, obviously you're going to need a battery and a starter motor. So we'll chuck them in. Have a battery, positive, negative. Now the negative lead on the battery goes to the earth of the motor. So that's just a symbol for earth, just like that. So we've got the negative. The positive actually goes to what we call a solenoid on the starter motor. So if this is my starter motor with the gears in there, off the starter motor there's a solenoid which has got 2 terminals on it, one there and one there. The positive lead goes straight to a massive big switch in here, and the solenoid, which is an electromagnet, so it's a coil of wire, has part of that coil of wire go off to an ignition key. So that's our key, and the positive obviously comes off the battery for the key, like that. When the key turns on, the solenoid does 2 things. It sucks in this way and it switches across these 2, and that takes a massive amount of amps, about 30 or 40 amps, into the starter motor coils. So the solenoid switches this big amp switch, and also the other end of the solenoid sucks the gear out and engages it into the ring gear. So that's our starting system. Next one is charging. So here again we need a battery, positive, negative. We need an alternator which is connected to the fan belt. So somehow the alternator is driven. And then we need to do 2 things to the power that comes out of our alternator. Sometimes it's done inside the back of the alternator, that's probably more common these days. But we've got to change the AC into DC so that we can charge the battery, because you can't charge the battery with AC. So we've also got to control the voltage so it doesn't go over about 14.7 volts. If it goes over that, it'll start blowing all our globes. So we've got to go through 2 processes. We've got to regulate it, which is some sort of regulator that controls the amount of current, so it's only 14.7 volts, and then we've got to rectify it, so we've got to change the AC into DC. With our DC volts, I'm not sure which one we do first, regulator or rectify it, but we rectify it, regulate it, and then we have the power go back to charge the battery, and obviously to go off to all our lights and accessories, radios and things like that. So we've got positive coming out of here, negative earth again, AC's made, changed to DC, then it's regulated down to a usable voltage and it goes off to our vehicle. Cooling system, that's pretty straightforward. we've got a radiator with some sort of coolant in it. There's the head of the motor, and then the block of the motor. The water is pumped by, well, we've got a fan here, and the fan's attached to the water pump which sits on the front of the motor like that. So the fan spins round, drags air onto the motor. The water pump takes water from the bottom of the radiator, so the water flows out of the bottom into the water pump. The water pump pumps the water through the block and then up into the head, through the head and out through the thermostat, out into the top of the radiator. So if your radiator's only half full, you're still going to have flow, so the water's flowing into the top. The thermostat controls the temperature of the motor. So when the motor's cold, the water's just flowing through the motor. As soon as it gets up to operating temperature, the thermostat here opens up and lets the water into the radiator to cool. If the radiator, it's a cool day and the motor's not getting hot enough, then the thermostat will shut it off. So that's our cooling system. A lot of cars these days have thermo fans which aren't connected to the motor, and they do the same job. Our ignition, we've got to get a spark, so we need our 12 volt battery, or 24 for some vehicles, trucks and things. Positive, negative, negative off to earth. The positive, just on our simple motors like our 202s and like, we've got a coil which changes 12 volts to 10,000 volts. So we've got to have 10,000 volts to jump the air gap on our spark plugs. So we've got our spark plug, there's an air gap here which we need 10,000 volts. So we have positive, and that goes to the negative side of the coil. Seems the opposite of what you'd normally do. Top of the coil, we've got a high tension lead which goes to our distributor. So it goes to the center of our distributor, and let's just make it a 4-cylinder just to be easier. So we've got 4 terminals coming out of the distributor. So the distributor has got a rotor in here which picks up the 10,000 volts that comes in and distributes it. It spins around and distributes the spark to the different spark plugs. So that one goes out to this spark plug and you get the zap at the right time. The distributor's also got in it a switch which we call the points, and that's operated on a cam like that, which spins around. Once if it's a 4-cylinder, it's a square cam, and it opens and closes this switch. And all that switch does is it takes the positive side of the coil and earths it. So that becomes earth. So every time this closes, the coil charges up. When this opens, the coil magnetic field collapses into another coil which has got thousands of windings and zaps out the 10,000 volts. So it's a very simple system. It's been around for a long time, over 100 years. Now we've got electronic ignition, which replaces our points, but our vehicles are pretty much using the same sort of technology. Okay, over the page, and we've got a lubrication system. So we need oil, and that's collected in the sump. So there's our sump, full of oil. That's our oil. In the sump there's an oil pickup which has got a strainer on the base, and then that goes through a tube up to our oil pump, however that works, a couple of gears, and then off the oil pump we've got a filter. So the oil's picked up from the sump, goes into our oil pump, through here, goes into the filter and out through the sides of the filter, and then is pumped into the motor through oil galleries. And there's an oil pressure switch here. When you turn the key on, you should have an oil light showing that you've actually got this system working. When the pressure comes up, it will turn that switch off, and that shows that oil is going out into the whole of your motor. If you're driving along and that oil light comes on, stop. You've only got a few minutes if you've run out of oil. So that's our lubrication system, and after this switch it's pumped up to the head and all through your main bearings and through the whole motor. So that's enough information for the lubrication system. Our fuel system, pretty straightforward. We'll have a fuel tank, some sort of fuel tank, and there'll be a pump. The pump could be on the motor, so there could be a fuel pump sitting on the side of the motor. There could be a small lift pump down here somewhere on some cars that lifts it up to the motor. Or a lot of our modern cars have got the pump inside the fuel tank. So somehow we pump the fuel through the fuel lines, maybe through a pump on the motor, up to the carby. The reason you've got a pump is because the fuel tank's usually lower than the carby or the fuel injection system. If it's a fuel injection system, it needs really high pressure, so you've got a really powerful pump here. If it's just a carby, it's a low powered pump. If you've got a motorbike, then the fuel tank is sitting above the carby usually, so it just gravity feeds out into the carby, so you don't need a pump. Some quad bikes and that do have a little pump on the back of the motor that's worked by the vacuum. Good idea in this line between the pump and the carby is to have a filter, especially on older vehicles or on an older motorbike. If your tank's starting to get a little bit rusty, first thing you do is put a decent filter in line to stop all the dirt. A lot of vehicles have a filter in the tank, so that's something that might need to be looked at if you've got fuel problems. So that's our fuel system. A lot of our fuel injected vehicles have the fuel pumped up to the fuel injection, and then they have a return line so that they control the pressure of the fuel going to the fuel injectors by a valve here which shuts off or opens up that return line, so it's just a continual cycling. Lastly, the exhaust. It's pretty straightforward. You're going to have a motor of some sort with exhaust ports coming out of the side of it. Make it a 3-cylinder, like our little Daihatsu. It goes through a catalytic converter, so the pipes go into a cat, which converts the harmful gases, your nitrous oxides and your CO, carbon monoxide, and your hydrocarbons, they all get combined in the cat. There's a chemical process before it goes into the exhaust, and it becomes CO2 plus water. So the catalytic converter is quite an important thing. Got an exhaust pipe, some sort of muffler which stops the sound, just baffles it, goes in, picks it up here. Another thing that your exhaust may have is exhaust gas recirculation, so there might be a pipe going up to the carby to allow a little bit of exhaust gas in to lower the burn temperature, so that's a possibility. You might have an oxygen sensor going off from your exhaust to your CP, just the control unit for the CDI, the engine control unit. And there might be air injection too. Some vehicles, to lower their emissions, just pump air from an air pump in so that there's more air in the exhaust so that they pass emission control systems. So that's a very simple exhaust. If you've got a turbocharger, the turbocharger is lubricated by oil that comes into the top and then lubricates all the bearings and then goes back down into the sump like that. What it does is it has the exhaust feeding into one side of it, which spools it up, and then the exhaust goes out, and the other side has the air intake from the air filter, and that's pushing large volumes of air up to your manifold. So that's another system you might find on your exhaust. Alright, so that's probably enough for our 7 systems of a vehicle engine.